Hello Stings, this is the video for the Unit 9 review, and we'll go ahead and get started. Question 1 asks what the value of C needs to be to complete the square. In other words, what does the value of C have to be for this to be a perfect square trinomial? So we take the middle term's coefficient, cut it in half, and then square that. So then C would be 25. In order to solve the quadratic function by completing the square, although 9 is a perfect square, it is not the square that we need, because half of this -8 is actually -4, and -4 squared is 16. So that's the wrong perfect square, so we need to move it out of the way and then add the perfect square to both sides. The reason we want this to be a perfect square is so that we can factor easily. What did we square to get 16? We squared -4. This is going to be 7. Now to get rid of the exponent, we need to take the square root of both sides. So we have x minus 4 is equal to plus or minus the square root of 7. Get rid of the 4 by adding 4 to both sides, and you have 4 plus or minus the square root of 7. For problem number 3, they want to know what the value of x is when g of x equals 0. So this is the column that we're looking at. Here's where g of x equals 0. So x equals 5 is the other solution. Okay, over here we have the parent function drawn, and I wanted to look at how the parent function was moved to get this function here. And they really just want to know when y equals 0. But what we did here was we went over 1 and up 2 to get our new vertex, and that is where we get a shifting to the right 1 and up 2 units. And it ended up to be wider because we found out that in class that if this were not a 1/2, then our points would be here and here. But as you can see, it has gone out wider from where those points would be. But we are looking for the solutions on this one, and so we have solutions here and here. So x equals -1 and x equals +3 are the solutions to number 4. For number 5, they want to know what the changes are. The negative sign means we have a reflection. The 2 means it got narrower because it's going to get bigger faster. And the 7 means that we moved up 7 units. Okay, so in number 6, all we wanted to do is show a correct substitution into the quadratic formula. So I'm going to go ahead and make the skeleton for this one. And I can't identify A, B, and C yet because I don't have one side equaling 0. So what we'll do is move this -16x and -16 to the other side. So if they were negative, we would have to add to both sides to get rid of those negatives. Then I can identify A, B, and C. A is 4, B is 16, C happens to also be 16. So the formula says -b plus or minus the square root of b squared minus 4 times A times C all over 2 times A. And this is all we had to do for this problem, was simply substitute values in. On the back, we now have to use the quadratic formula to solve. So this time, we'll go ahead and make our skeleton, but we're going to have to solve. We're not just going to substitute in, we're going to actually go through the process of finding out x equals. So first off, we see that it is equal to 0, so I can identify my A, B, and C. A is 4, B is a +5, and C is a -6. So then we substitute these in here. -b plus or minus the square root of b squared minus 4 times A times C all over 2A. So our next step would be to start simplifying. So the opposite of 5 is -5 plus or minus the square root, and then 2 times 4 is 8. So we're going to take and find the square root here. Sorry, I take that back. We're going to find the discriminant underneath the radical here, And if you put this into the calculator from this parentheses all the way to this one, making sure that this is a subtract and this is a negative, you're going to end up with 121. And 121 is a perfect square, and its square root is 11. So then we're going to split this up into -5 plus 11 over 8. Or our other solution would be -5 minus 11 over 8. So this is going to be x equals 3 over 4, or x equals -2. You may need to use your calculator and alpha y equals to make sure that you have simplified these fractions correctly. For problem number 8, this x plus 6, remember that's the same as x minus -6. So this tells us we have a left shift. We're shifting to the left 6 units. And the +2 here says that we are going up 2 units. So this is a vertical shift, this is a horizontal shift. Problem number 9, the graph is shown here. They want the positive value of x for when the function equals 5. So they want to know where y equals 5, what are the x values? So here's y equals 5. So we see that that cuts through here and here. This value of x is a -2. This value of x is a +6. They want the positive answer. So for this one, x equals 6. Then finally, problem number 10, we need to identify all of the characteristics. Here's our vertex at -2, +4. This is a maximum. The domain of all quadratics is all real numbers. The range we get from the vertex, the y value is 4. Because it's a max, we're going to use less than or equal. The axis of symmetry comes from the vertex, x equals -2. The zeros are our solutions at x is -4 and when x is 0. And our y-intercept actually happened to be at the same location as one of our solutions. And that was at 0, 0. So this has been the Unit 9 review for your test.